Okay, let's go ahead and finish up the exponent properties quickly. The first property that we need to talk about, the technical name is same base quotient. It's found in section 5.2 in your textbook. But in plain English, all it is, you have a fraction, you have a variable in the numerator and a variable in the denominator, and they're raised to different powers. Just different ways, just some simple ways that you can simplify this. And the most basic way to simplify it is really using common sense, because you can look at it and count the number on top and the number on bottom, and then you can cancel out common factors. But the first problem here is number 18 on page 192, a basic illustration of this property. And you can see here's my fraction. And if I write it out like this, which you don't have to when you're solving it, but just to explain what's going on, r squared is r times r, and s to the fourth is s times itself 4 times, and then t is just sitting here, t to the first. My denominator, r times r, 1s, and t times itself 3 times. And you can see by looking at this, you can eliminate one r on top, one on bottom, and you can just go across with your eliminations. 1t on top, take away 1 on bottom, and who's left standing? I have 3 s's on top and a pair of t's on the bottom. The property says that a way to calculate this, you can write each variable one time, and then it's the top power minus the bottom power. So if I write r one time, and the top power minus the bottom power. If I write s once, it's the top power minus the bottom power. And writing t one time, it's the top power minus the bottom power. Now coming across to clean this up, well, 2 minus 2 is 0, so that's r to the 0 power. S is now cubed, and t is to the power of negative 2. We'll talk about the other properties later on in this video and in our next class, but anything raised to the power of 0 is 1. And I have s cubed, I have a positive exponent, so this simplifies as s to the third over t to the second. When the exponent's negative, you write the reciprocal of the base or put it on the other side of the fraction bar, and I will talk about that in a minute. But basically, when you have same base quotient, just means you have the same variable top to bottom, and just write the variable once, and it's the top power minus the power on the bottom. And then we will address negative exponents later on in this video. Here's another example, and this is using a property that we learned earlier. I now need to apply or distribute the cube to each term in the numerator, and I have to square each term in the denominator. So go ahead and perform that. So I have 125 a to the 6th over 25 a to the 6th. You can see that 125 divided by 5 is 5. Write a one time, and then just apply the property. Top power minus bottom power. This gives me 5a to the power of 0, which is just simply 5. And you could have easily reduced this without the properties, but I'm just showing you the example so that you know that the properties do hold true. The next property, again with fractions, I have a fraction, and outside the parentheses, I've raised the entire fraction to a power. The way you interpret this power is applied to the numerator and to the denominator. So you can rewrite this expression in this manner. This is how you would go about solving it. So here I have a simple example, and right off the bat, I see that I have a negative number raised to an odd power. You could think of that as negative 1 cubed, and you know that that will remain negative because you'll have a pair of negative signs to cancel each other out. But there's always the oddball negative sign left over, making the entire expression negative. And I have x squared, cubing that as x to the 6th. And then I have to cube the 3 in the denominator as well. Let me erase this. Okay? So applying the cube to the negative sign tells me the entire expression is negative. The numerator now becomes x raised to the 6th power, and the denominator is 27. 3 times itself 3 times is 27. So that's an application of that property and how it would look in a problem. Okay, here's the next example. Using this same property, power of a quotient. I now have a product to calculate, but it's still the same. So this expression is cubed. This expression will illustrate my property. So I cube each term. I'll have 3 cubed and x cubed, and then the y also gets cubed. So the power here gets applied to each term in the fraction, and this will be multiplied by y over 9. So this looks like this. My numerator becomes 27x cubed y, and my denominator is 9y cubed. 27 divided by 9 is 3. I have no x terms in the denominator for canceling. I don't have any x's here, so x cubed remains in the numerator. And applying the last property, calculating the variable on y, you could write y one time, and it's the top power minus the bottom power. So this looks like this, 3x cubed y to the negative 2. And if you're asked to rewrite this with positive exponents, your answer would look like this. 3x cubed on top, y to the second on bottom. Next problem up, just a property to make sure everybody understands, negative exponents. And here's your basic layout of the property. To rewrite it so that the exponent becomes positive, just simply place the base and the exponent on the other side of the fraction bar. And when you do that, the exponent becomes positive. So here's my first problem. To rewrite this so that both exponents are positive, you take the reciprocal of the base, or simply write the base and the power on the other side of the fraction bar. This would be implied as over 1. So to rewrite it so that these two exponents become positive, you would put 1 in the numerator and then a squared b cubed in the denominator, and you can see when these expressions are written in the denominator, the powers become positive. Here I could use the very first power of exponents, the very first property that we learned. Write the base one time. When the bases are the same, add the powers. This becomes a cubed. Or you could think of this problem as a to the 5th over a squared. And when I put this a squared in the denominator of a fraction, the power becomes positive. And then you could apply the property that we just talked about. Same base quotient, write it one time, and it's the top power minus the bottom power, giving you a cubed. So the properties all support each other, and you can solve with the property of your choice. Here are some problems that we will do in class together, but I would like for you to at least copy the problems in your notes. These are the higher level problems or the more multi-step problems. We also will discuss what happens when the exponent is 0. We will discuss reasons for the negative exponent, and we have one more problem set to do. These are some on page 334 and 335, a property that I would like to make you all aware of as well.